Welcome back to InTooDeep. In this episode of InTooDeep, I'm going to install an off-grid system that is capable of running my 70-foot floating home out on anchor as if it were plugged into the dock. If you've been watching for a while, you might have seen me install an off-grid system into my old 50-foot Hatteras a few years back. It worked spectacular, but my power needs on that boat were just a fraction of what this old 70-footer needs to operate. It quickly became apparent that I would need to run my generator whenever I didn't have access to shore power, just to power vital systems like ventilation, lighting, refrigeration, battery chargers, fresh water pumps, appliances, entertainment, air conditioning, and so much more. Even the windlass to haul up the anchor is 240 volts on this boat. I knew it was going to take a heavy-duty system to keep up with my power needs. So grab your popcorn and hop aboard to watch me upfit the Broward with a state-of-the-art marine-compliant off-grid power system. Alright guys, right now I'm going to draw a quick outline of this entire system so you understand what's going on. It's relatively simple and it consists of three major components. So join me as I draw a terrible diagram of the boat and the components of this system. Alright, so right here is the terrible diagram of how this system is going to be set up. Right now, none of this exists. It's just a generator and the main electrical panel. So the generator's power is plumbed directly into the main electrical panel. You flip a switch depending on whether you want shore power or generator power, and now you're powering the main electrical panel off of the generator. The basis of this system is I'm going to cut the wires that go from the generator to the electrical panel and plumb the generator's power into the inverter. It's two phases, a neutral, and a ground. This is the exact same power that comes into every household in the United States. It's two legs of 120 volts that are out of phase from each other by 180 degrees, meaning between the two legs you have 240 volts, and from each leg to neutral you have 120 volts, so that you can power all of your 120 and 240 volt systems and appliances. The inverter has an output. The power that comes out of the inverter's output depends on whether the generator is running or the generator is off. Regardless, it has two phases, a neutral, and a ground. These 8 squares right here are the batteries. These are 48 volt Epoch LiFePO 4 lithium iron phosphate batteries. And they are going to be connected to the inverter. So in a nutshell, the way this system is going to work is when the generator is running, it is supplying power to the inverter, and the inverter's built-in transfer switch is in bypass mode, which means the generator's power is coming into the inverter and then coming out of the inverter and powering the electrical panel, which is the loads of the boat. In addition to that, the inverter charger has a built-in AC charger. So while the generator is powering the loads through the inverter, it is also charging the lithium batteries. As soon as you turn the generator off, the inverter switches over instantly to battery power to continue powering the boat's loads off of the batteries. With a system like this, the boat will never lose power. Unless, of course, the generator breaks down or the batteries die. I'm sorry about the terrible diagram, but I think it's all gonna make much more sense right now. Alright, so I've decided that it is in my best interest to show you guys the installed system with all of the components, and then I'll show you the installation after. That way I can explain everything in its operation, you can see it working, and I think it'll work better like that. So from the main salon, we're gonna find our way walking down the stairs. And when you turn forward, you see this closet. Open up said closet, and right here is my Sun Gold Power 15,000 watt split phase inverter. Massive shout out to Sam Mays. He is the reason that I have this inverter. he reached out, sent me an email and said, what inverter do you want to use for your off-grid system? I told him it was this one. Next thing I know, this thing showed up at the marina up in Maine. It took a long ride on the boat with me prior to it getting installed, but now here it is doing its job. Thanks, Sam. Here's the installation right here. Basically, you have two legs of 120 coming from the generator. They go in to the inverter. And then here you have two legs coming out and then a neutral and a ground, which are common. Right here is a gauge. One of these gauges comes with each and every Epoch LiFePO4 lithium iron phosphate battery. In my case, I have 8 gauges because I have 8 batteries, but I only need to use one of those gauges because of the ability to network the Epoch LiFePO4 batteries together. Right here is a Victron Smart Shunt. This is a Bluetooth 1000 amp shunt that allows me to see how much current is going into or coming out of the batteries, in addition to a couple other things like voltage, state of charge, and it is also programmable. So you see these two wires here. These are coming from the port side battery bank, positive and negative, and these are coming from the starboard side battery bank, positive and negative. If we back up here, we'll head over to the port side first. Right here, underneath the port side berth, inboard, if I open up this cabinet, you will find 4 of my 8 Epoch LiFePO4 batteries. I've never done a video like this where I work backwards, showing you the finished product and then showing you the installation, but I felt this was important because I wanted to feel really good about talking about these batteries. These batteries have impressed the crap out of me. In fact, so much so that they're actually outputting more than their rated capacity within every charge cycle that I've used them for so far. Each one of these batteries is 100 amp hours, but keep in mind, they're 48 volt batteries, so that's equivalent to a 400 amp hour 12 volt battery. Meaning this 400 amp hour 48 volt bank is equivalent to a 1600 amp hour 12 volt battery bank. And this is only half of my battery bank. The other half is on the other side. That means my total capacity is 800 amp hours at 48 volts. That's equivalent to 3200 amp hours 12 volt. So when I was doing my research to select the batteries that I wanted, I had a couple things in mind. Firstly, I wanted them to be waterproof and marine compliant batteries. In my last system, I used server rack batteries. They weren't bad, they worked great, and I'm sure they're still working great to this day. But in the event that they got wet, there's nothing keeping the water from getting in there. So one awesome thing about these Epoch batteries, they are waterproof. They're IP67 rated. The compartment that I have them in down here is completely dry, but it's really for peace of mind and for just being in compliance, which brings me to the next point. These Epoch lithium batteries, or I should say lithium iron phosphate batteries, are ABYC compliant as well. ABYC is the standard yacht building practices. It's a series of standards that boat builders use to make sure that all these vessels stay in compliance with one another. It's also a series of standards that surveyors use when they are inspecting boats. So as you come down here, you see that I have these 4 batteries and then I have an identical bank on the other side. Right there is a Victron Lynx distributor. It's basically a fancy bus bar, but there's also some electronics inside of it that allow you to connect to one of Victron's shunts. I forget what that shunt is called, but it's basically a shunt that can go in line with this. I use the smart shunt, so I didn't buy that shunt, but this is a much better way of connecting your batteries together than daisy chaining them. Daisy chaining actually has some cons to it. In fact, it's in Epoch's manual. Check this out, I found this pretty interesting. Bus bar system. Advantages: equal resistance and uniform charging, simplifies adding more batteries, reduces voltage drop, facilitates battery isolation. Daisy chaining. Advantages: simpler implementation in smaller systems, Considerations. Can lead to uneven charging and is less scalable. You might notice that each one of these batteries has a label that I made. This one says master, this one says slave 1, slave 2, slave 3, and then on the other side is slave 4, slave 5, slave 6, slave 7. For a total of 8 batteries, and these batteries are daisy chained together. Let's go over to the other side real quick so I can show you those. All right, here's slave 4, slave 5, slave 6, slave 7 with another Victron Lynx distributor. But real quick, I've got to talk about the way these batteries are linked together. So as some of you might know, LiFePO4 lithium iron phosphate batteries have something called BMSs, battery management systems. They're in charge of controlling all of the cells inside of each battery to make sure they stay balanced, the batteries don't get overcharged, they don't get too discharged, you don't draw too much current from them at once, they don't get too hot, they don't get too cold. And by networking these batteries together, it gives all the BMSs a way of communicating with each other. So not only do the cells in each battery stay balanced, but each battery stays balanced to one another as well. In addition to that, these batteries have built-in heaters, so if they get too cold, they will warm themselves up. They have internal fuses, which is part of that ABYC compliance thing. So if you draw too much power or you have a short circuit, you will blow the fuse in the battery and you do not risk shorting and destroying your cells. The cases are flame retardant, although the risk of spontaneous combustion with lithium iron phosphate batteries is slim to none. Out back here, you might notice these dip switches. I have each battery set to its corresponding label and its corresponding position in the daisy chain network system. It's extremely easy to set up. Epoch's manual is spectacular. I've been using these batteries for well over a month now. They're performing amazing. But before I talk any more about them, I want to show you the entire installation process from me getting the batteries delivered, getting them in my truck, getting them on the boat, mounting the inverter, running all the wires all the way through the floors to the engine room, making all of these cables custom. I crimped every connection. This system is purely custom. It's not as custom as if I were to have made my own batteries out of lithium iron phosphate cells. I did a lot of research on building my own LiFePO4 battery bank out of cells from China, and it's very easy to do. The problem is it's really not very safe.
It's right in the crease where it's right in the crease. It's in the crease. It's in the crease again.
Okay, that's perfect. That's good.
Actually, that'll work.
What we'll do now is, oh yeah, we have to push more. Yeah. No. So let it down. A little bit. That's good. Yep. So lower this down. We'll get the jack further in now.
There you go. Woo! Wow.
Wow.
Nice work.
Looks good, man.
Nice work, boys.
All right. Thank you. Wow.
Holy cow. It's like a package like a Fort Knox. It's in a whole plywood box by itself.
Yeah, they take shipping lithium batteries on airplanes very seriously.
Oh yeah.
I bet you the FAA has to inspect the packaging before it goes anywhere.
Yeah.
Epoch.
Epic. Epoch. Holy cow. Wow. Oh my God.
These are the real deal.
Everything's like quadruple packed.
That's awesome, though.
Holy cow.
Wow.
Finally, there's the battery.
These are reasonably sized. That's awesome.
There's the battery. That's it.
That is a good looking battery. These things pack a punch. Each one of these packs a punch. These batteries are no joke. Wow, look at that.
Wow.
Alrighty. So we just got to the boat with the bats. Oh yeah, I have to clamp this walkway. But for now, let's just put the batteries right here.
Okay, let's unload the batteries.
Let's unload. All right, cue battery unloading time lapse. We're gonna break this pallet down and make it happen. Alrighty, this is a pivotal moment in InTooDeep history. We only have a couple pivotal moments per year, if that. And right here lays enough power to power this vessel for quite some time. What do you think, Dad?
Well, we got the batteries out of the boxes. It's going to be an awesome construction project.
Yeah.
Putting the whole system together.
Yeah.
And adding it in.
Yeah. It really will be. I'm ecstatic. And so they're not that heavy. I mean, these are the size platform of an 8D battery.
Wait a minute. These are pretty heavy.
Yeah, but
for Gus, they're not that heavy.
a lead acid 8D battery is at least double the weight of this.
Yeah.
Yeah.
There's lead in it.
Yeah. I mean, this is.
But they're pretty heavy.
These things pack a punch. Their power to weight ratio is uncomparable to lead acid.
Yeah. Plus, their capacity. And they can be drawn down very low.
Yeah, that's another big thing. With lead acid batteries, you can really only use 50% of their true capacity before you start damaging the battery. With these, you can draw them down until the BMS shuts them off.
Each one has a computer in it, so each one has its own monitoring system built right into it.
Yeah. Yep.
And they all have a CAN bus to talk to the master controller, and
not to mention it's totally networkable with Victron controllers straight out of the box.
Yeah,
straight out of the box.
Digi switches probably put the address of the battery.
Oh,
these have to be set up so each one is unique
in the monitoring system.
Yeah.
Yeah.
So it knows which battery it's talking to.
Yep. Yeah. Not only that, but it comes with gauges for each battery. So I'll set up a whole gauge panel.
So you can tell if there's a battery that's not feeling well.
Exactly.
Yeah.
Exactly, which is very important.
And yeah.
Wow.
Absolutely. Because especially since they'll all be in parallel.
Yeah.
Yeah.
So I talked to the engineer that pretty much put these things together, and he said that they are they're one of a kind. They're some of the latest and greatest technology that is incorporated into lithium or LiFePO batteries. I'm ecstatic. Their platform is amazing. These are the exact same capacity as the batteries I put in the Hatteras, except these are IP67 waterproof. These are definitely a little bit lighter than those. They're not in a metal case, which is amazing. I think just about everything is better about these. Not that those batteries didn't work good, but these I have high hopes for.
Technology moves quick in this industry.
Yeah.
Yeah.
It's a lot of batteries. All right, let's get them in the boat, shall we?
Let's do it.
So me and my dad just shuffled all of these batteries down the stairs and into the rooms. Here's the plan. I have 4 of my Epoch 48 volt 100 amp hour batteries in each of these staterooms. Here and there. And they are going to be I'm going to be putting them under here on both sides. I have these nice cabinets. It's going to be perfect. So, 4 are going to go under there. And then 4 are going to go under here. Before we get into that, this is the part that I've been dreading. I need to mount the inverter. Big shout out to Sam. He wanted to help out, so he helped me out buying this inverter. And it's quite the unit. It weighs about 200 pounds, so while I have my dad here, I need his help mounting it in this closet. What do you think, Dad?
I think maybe this is the last time my back is okay. Actually, if I survived all those batteries, each one of those batteries is 100 pounds.
Yeah.
Oh, man. I'm not, yeah, feeling the age,
I don't think most people on here would believe how old you are.
Let's not even get into
it. He's in damn good shape. He's way stronger than me.
Not really.
No, you are way stronger than me.
No, I don't think so.
So I set up the piece of foam that they had the inverter mounted on in the box and used it as a template. Drilled some holes here and here and have my studs ready to go for hanging this thing. What I didn't realize is that, I should have realized, is that they came right through the wall. So I'm gonna hang a beautiful picture right here on both sides or something of that nature. It's time to get this inverter mounted. It's gonna be a shuffle and a scuffle. Wow. Let's see if my holes are right and we can hang it. Should work out pretty well.
So we're gonna have to come in sideways with the back end going in first.
Mm-hmm.
And then lay the back in on the foam and then tilt it up into the closet.
Okay.
Right?
Yeah.
So
wow, this end is way lighter. Well, I'm almost wondering if it would be the easiest to do this single person.
Whoa, Gus.
All right, I'll tell you what. Lift on that end. Lift that end up.
This end?
Yep, lift. Lift it all the way up so it's standing up straight. Like that. All right.
You got that, man?
I got it.
Okay.
That thing's heavy though.
Or you don't got it.
I got it.
That or you don't got it.
I got it. All right, tilt it up.
That's what I thought we were gonna do with 2 people. Wow, dude. You're an animal.
That's heavy. Holy crap.
Yeah, so now you gotta like twist it. Turkish twist.
So some of you might be thinking, that's going to be one very hot closet. Well, if you look right here, down at the bottom, there's a nice vent. And then I got this to go at the top. And this is going to suck the hot air from the top, cold air through the bottom. And this has a thermostat, so it'll monitor the temperature of the closet. And if it gets too hot, it actually beeps. So that's pretty cool. Alright guys, right now it is time to go over some of the vital components of my off-grid system here. So, firstly, this is the model of Epoch battery that I have. It is their newest 48 volt Marine LifePo 4 battery. Each one is 100 amp hours, which is equivalent to 400 amp hours, 12 volts. Now, In the past, I have daisy chained my batteries together. Come to find out, that is not a very good way to do it. There's a small amount of resistance within each daisy chain connection, which leads to a very small voltage drop, which can very minorly confuse the BMS. It will work. It worked for me fine many times in the past, but it's not ideal. So this time what I decided to go with, based on the recommendation from Epoch's engineer actually, is these Lynx distributors. They're made by Victron. I have 2 of them. Your negatives go in, your positives go in, and out comes your 2 big lugs. So you're bus barring the batteries together, just in a smarter manner per se. You'll see them mounted and connected shortly here. Tin coated lugs with 5/16 sized holes for the Lynx distributor. Right here is all of my wire that's going to go from the batteries to the Lynx distributors. It's 1/0 cable, marine cable, tin coated. And from the Lynx distributors to the inverter will be 3 or 4/0, depending on the length. I need to still measure that. But I have this, so that's good. Right here is the SunGold Power remote display. That's going to go at the helm with Cat5 wire to run from the inverter up to the helm, so you can control the inverter and monitor the inverter from the helm. Right here is a Victron 1000 amp smart shunt. This goes right in line your main ground going to the inverter, and you can monitor state of charge, charge rate, discharge rate, and all sorts of things. Anything that your typical shunt can do, this can do. It just transmits its information via Bluetooth, so you can monitor it on your mobile phone. I'm not sponsored by Victron, but I do like their products. While we're talking about all of the components, I want to show you what each one of these 100 amp hour Epoch 48 volt lithium batteries comes with. Firstly, this is a remote power switch for the batteries. I don't think I'm going to be using these because I have the 8 batteries in parallel. I don't see why I need to control their power remotely when I can just go under the berths and shut them on or off if I really need to. You have your Victron network cable, and then you also have your analog CAN bus network cable. But if you do want to network your Epoch batteries with a Victron device, you absolutely can do that now, which is really cool. It takes out the middleman, essentially, and it lets the Victron communicate with the Epoch battery's BMS, specifically. In addition to that, each Epoch battery comes with a state of charge and voltage indicator, gauge. I'll probably mount these in the closet that the inverter is in. It's cool to have. You can see each battery individually, although you can do it on the mobile app as well. Now you can do it with an analog, well, digital gauge. All right, so I have something to add real quick. You just heard me talk about the power switch and the gauge. What I didn't realize at the time was that the power switch will actually control all of the batteries in your bank if you have them networked together via the CAN bus network like I do. And the gauge will also display the data for the battery bank as a bank. Also, when I first powered up the batteries, I couldn't get them to connect to the app. That's because the Bluetooth transceiver is in the gauge. So you have to have the gauge hooked up, whether it's one battery or a bank of batteries, to monitor them via the app. All right, let's talk AC wiring. So obviously I have to run AC wires all the way from the inverter to the engine room and then back. So right here is 6 gauge duplex marine tin coated wire. This is the real deal. This wire is the real deal. Let me show you how thick the conductor is here. I think I opened one of them. Maybe not. Oh, right here. This wire is the real deal. It's some really thick stuff. So I think the most time-consuming process of setting up this off-grid system is going to be running all the wires back and forth. They need to go from the inverter through a chase up under the helm, through the helm, and then down into the engine room. It's going to be quite the wire run, so I might need to find someone to help me with that, but I might be able to do it alone. Each one of these spools is 50 feet. The reason I went with the duplex is because I couldn't find tin coated triplex, which is really what I would have needed. So I just got 4 spools of this. I probably won't use it all. This here shrink tube is so that I can shrink tube all of my connections once I crimp them with my little hydraulic crimper. So yeah, I think we've pretty much gone through the basis of it. So now it's run wires from the batteries to the Victron Lynx distributors, and then to the inverter, and then from the generator to the inverter, and then the inverter to the main electrical panel for the boat, and then we can boot this system up. So I'm gonna run some wires now. Alrighty, so right now we are under the starboard side berth, and I just mounted the Lynx distributor. The cover's off it, that's why it looks different. So you can attach all the wires. I mounted it right there, and now I'm gonna start crimping wires. So I'll see if I can set up a time lapse so you can watch me size, crimp, size, crimp. What I'm gonna do is crimp an end on the spool, attach it to the battery so I know exactly the length that I want it. Should come out perfect. Alright, so now I have all my wires cut to size. Now I also have one end crimped on there. So what I'll do is I'll hold them up to exactly where they need to sit, and I'll make a black mark with a Sharpie so I know exactly which direction I want to crimp the terminal on the wire, so that I don't have to like stress the wire and twist it sideways. By the way, that nasty scar is from when I got my grinder stuck in my hoodie strings. Flash video. So I'm just over here grinding away at the prop shafts and doing the bow thruster and whatnot. And I fell for a classic. This is a classic one. So these little strings that hang out of your sweatshirt, seen all the videos of people getting their faces caught in drill presses and stuff. Well, I got myself caught up in that thing, and I sliced myself open pretty good. I don't think it's ever going away. That's a crazy one. I've had people ask me some gnarly questions about that one. It's not what it looks like. All right, all my wires are out of there, labeled and ready to go. I'll shrink tube them after. Let's have a crimping party, shall we? And just like that, I have 8 properly finished, crimped, and shrink tubed battery cables for the starboard side. Now I just need to repeat the exact same thing on the port side. I'm gonna install these first to make sure they all work out nice. Alright, so I'm here on the other side now. and I am going to show you what I've got going on here. So, in here, I have removed this access panel where you can actually gain access to the engine room bulkhead. So originally, I'm going to show you a little in here. It's going to be kind of hard to see, but originally my thought was this is the center of the boat in here. I was going to run the cables all the way through there and then up under the pilot house, over, and then down into the engine room. But I discovered that I was able to drill through the bulkhead. So I'll run the wires through the engine room bulkhead down there and then forward to the generator and the electrical panel, and then from there straight aft. Actually, I'll probably come over here on this side. Interestingly enough, this is actually the top of the main, or not the main, but the day tank, the day fuel tank. So there's 800 gallons of fuel stored in here. And it looks like it's coated with some nice greasy something that's keeping it from corroding, so that's good. But these AC lines are scary, man. I disturbed them and they dripped a little, but I realized that they didn't drip because they're leaking. They dripped because the cold water traveling through them on a hot, humid day creates condensation. So that's that. Anyways, I wore out my only hole saw. That was the right size, so tomorrow I have to go get a new hole saw. Then I can finish drilling the hole in the engine room bulkhead to run the AC wiring. So now I'm going to do exactly what you already saw me do on the other side. On this side, I'm going to mount the Lynx distributor and make my wires for these 4 batteries. Then the only remaining DC wiring I'll have to do is from each Lynx distributor, the main connections to the inverter in the closet, which is on the other side of that wall. Here we are in the port side aft guest stateroom. I realized that I don't have enough lugs. I need 8 more. So I need to go to West Marine tomorrow. I'll add it to my list. I'll measure exactly what I need for wire from the Lynx boxes to get to the inverter. And then I should be all set. I'll get more crimps and we'll be good to go. But they're all sized up. The Lynx is mounted, so essentially this is halfway done. Everything's labeled. So we're good to go for tomorrow. Sweet! Getting her done. step by step. Alrighty, so I just got home from West Marine. It's the next day. I've got two spools, two 20-foot sections. Well, actually this is 25 because that's all they had. I had to buy it in a spool, but of 2-watt battery cable, marine battery cable. So this is one size thicker than what I use to connect the batteries. According to my wire gauge size chart, this is perfect. And then I got all sorts of other goodies. I had to go somewhere else to get the fuses that I needed to connect the Lynx control boxes. They have fuse slots. These things are expensive. They're like 12 bucks each. And I had to get 325 amp ones because they only had 500s and then 3 125s. It'll be alright. So I got the lugs that I needed to do all of the AC wiring. And then I also got the lugs that I needed to finish connecting all the batteries together. Got some wire ties, and for the AC wiring running through the engine room, I got some loom. And then I got all my 2-watt connectors for running the big cables from the battery banks forward to the inverter. Now, the only thing that I did not get is the 4-aught wire that I need to connect the two sides together to the inverter in the closet here. So essentially, my wires are going to come through the floor here, and they're going to meet up down here, and then I need 4-aught wire to go up to the inverter. For now, I'll use the 2-aught to test everything, and then I'll make my way over to a different West Marine to get the 4-aught wire. But until then, I think what I'll do now is finish crimping all of my connections for this side. Alright, so somehow I miscalculated. I don't know how I did that. Just stupidity. And didn't get enough lugs. I still need 2 more. But what I did do was I ran the wires from each Lynx distributor box aft into here. And I'll make holes in that floorboard so that the wires can come up. And then I'll have my smart shunt there. I won't need a fuse because this thing is internally fused and each battery is internally fused. So I should be all set there. If there was a short in one of these wires anywhere, it would blow any of the fuses on the Lynx distributor. And if there was a short south of the inverter, it would blow the breaker on the inverter. If for some reason it didn't, then it would blow either one of the fuses in the Lynx distributor, or each battery is internally fused as well. So that's perfect. I'm going to leave this as it is for now because we're going to go run the AC wiring now. Alright, so we're in the engine room right now, and I'm going to come down here and show you where I'm going to have these wires come through. So, right in here, I started drilling last night, made a nice hole, but then my hole saw wore out right as I was getting through the bulkhead. So, today, I came back with the hole dozer. Straight from Ace Hardware. See if I can punch a hole right through that bulkhead. And no, don't worry, this little hole is not gonna affect the boat's structural integrity at all. There's many little holes down here where tubing comes through and stuff like that. I'll properly insulate it when I'm done. I'll use a piece of hose to make a nice path through there, and then I'll pack the insulation back in there. It'll be perfect. This is much better than running the wires forward into the helm and then back down and around. The wires are going to come straight from the inverter, and they're going to come all the way along with all the other AC wiring to the generator and the electrical panel. Alright, and just like that, our hole is drilled straight through. I don't know if you can see, but it is thick. I mean, you're talking at least 8 inches of thickness there between the insulation, the aluminum bulkhead, and then the other side that's also insulated and then has a wooden backer on it. The hole saw fell through the other side because I had to make an extension piece here, so it was just sliding in and out. But I'll go get it, and let's find a piece of tubing that fits nicely in this hole. So I've located the perfect little piece of tubing to go right through and in there. Just like that. I could even leave the extra actually if I wanted to, and then the wires would come out. But I think what I'll do is I'll cut it close to flush, because I'm gonna run some other wires through here too. I'm gonna run the wires to the Garmin in the aft stateroom here, so that way I can monitor the anchor alarm on a 3rd Garmin unit from my stateroom. And I'm gonna run the inverter control panel wires through here, because those are going right alongside the AC wires to the inverter. Alright, so here's my AC wires going into the hole. Everything's labeled. I labeled the spools and I labeled the end of the wires, so I'll be good to go there. I could really use a second person snaking all this stuff in. I'm gonna try it. If it gets caught up, I'll just wait for someone to help me feed it, because I don't want to like chafe the insulation off the wires because I'm yanking on them, or I don't want to yank on them. So, all right, let's give it a shot. All right, so after a long and grueling process, I ended up doing it by myself. I'm gonna show you where all the wires run. So these are my 3 sets of wires. The hots in, hots out, and then neutral and ground. It's duplex wire, meaning there's 2 6-gauge wires in each bundle. So it goes through, the wires go through and they feed back to the inverter. And then I just ran the remote communication wire from the helm down here. I'll route this nicely so it contours with all the other stuff. But I'll take you upstairs and show you what we're dealing with now. I'm gonna take this drill with me because I'm gonna make the holes in the floorboard to run the wires through. Okay, so from the helm, here's the other half of my communications wire. It's just a Cat 5 cable. And I was very careful not to bend it sharply. This right here is the remote panel, which is gonna go right here. I'll cut a nice hole out for it. All right, now we're gonna go downstairs, down below. So in my newfound electrical closet, we now have positive and negative from each side battery bank. And then we have all of our AC wiring with some extra to spare. And then we have our inverter remote control panel communications wire. So that's everything we need for the inverter. So I'm going to take my floorboard and figure out exactly where I need to make the holes to make all this look great. Let's do it up. So I'll say, let's go here and here. Let's go here and here. And then communications can come up right here. And then the AC wiring can come up. I I guess right here. Perfect. Let's drill some holes. All right, so I have successfully routed all of these wires through their nice little sections here. Got our base plate back in place, and now I'm gonna mount the shunt. So what I'm thinking for the shunt is basically both of the negatives from the load go to the shunt. So I might mount it like that. Well, I'd mount it like that. That's what I'm thinking. Then the negatives will come up, and the load to the inverter will go right to that negative post. Let's do it up. So I have got the walls placed back in their respective spots, and I've got all the wires coming through, stripped, labeled, cut to length. The shunt is mounted. Now it's time to start crimping and attaching. Sweet. All right, it's time to make the last couple of crimps and all of our final connections. Let's put these super expensive bus fuses in. I know they say 32 volts on them, but I was reading that it's okay to use them. They're oversized anyhow. The batteries are internally fused, so I guess the worst thing that would possibly happen is they blow, which I highly doubt it, because that would mean I'm drawing in excess of 800 amps off of the bank, which should never happen. Alrighty, so the last step of this side of the system, the DC inverter side, is I need to crimp ends on the two wires that come from the inverter and go to the Lynx distributor box. I like the Lynx's. That thing is pretty cool. It neatens everything up very nicely. Look at that. Then the nice cover fastens right on there.
Would you look at that?
Pretty cool. What I really like about this setup is if I want to, I can expand and add a Victron GX like battery monitor system. The batteries can network to the system. The Lynx distributors can network to a Victron smart shunt. Although I have the Bluetooth smart shunt, but looking back, I should have got the Lynx shunt, because then it actually references the distributor instead of having the shunt over there. I'm gonna finish crimping up this side, crimp up that side, connect it all, leave the two positives off of the inverter, because there is something that I would not have thought of that the Epoch Battery engineer informed me of. These big inverters have massive capacitors in them, and if I were to just connect the DC power, those capacitors need to be charged, which takes an insane amount of current. It would blow either one of the Lynx fuses or one of the internal fuses in the batteries. So what I need to do is connect the AC side first, because apparently you can charge the capacitors by powering up the inverter with AC first. So what I'll do is I'll get all this set up, I'll connect the whole AC side, figure out how I'm going to do that with the generator, and then I'll send AC power to the inverter and charge the inverter per se. And from there I should be able to connect DC power and test it all. I am so excited to have this, and I'm going to the Bahamas soon, and this is just going to be a game changer. Now I can run the boat off of batteries sometimes. So the one big question that I'm sure everyone's wondering is, can you use the main engines to charge the battery bank? Yes, there's different ways to do it. The best way would be for me to get like a smart 48 volt alternator on each engine. Another way I could do it is by connecting the engine batteries in series after the engines, since they're lead acid batteries, they're pretty resilient, you know. It's not like a sensitive electronic component. So if I were to connect the batteries like that, I could use a 48 to 48 volt DC to DC converter and charge them off the engines like that, or to use a 24 volt inverter to charge them via AC, I think would be completely ridiculous. So that's a lot of power lost in efficiency. I'm probably gonna look into 48 volt alternators, but for now, this is gonna chop my generator usage in half, just being able to have these batteries. If I wanted to, I could add solar, but with a system of this size, you would need so many panels to really make a dent that I'm more after utilizing the generator's unused power while it's running, and then being able to shut the generator off and harness battery power until they get low and I start the generator back up. Alrighty, so the time has come to, from the engine room, set all these wires up. So my plan is I'm going to take the cover off of this generator control box, because these are the wires that I'm after. These go from the generator's output into the electrical panel. When you select starboard gen, and then you select starboard gen and starboard gen, you connect this circuit into the loop. This is for the air conditioning, and then this is for the ship service. So it's sort of like the old hat, where, except this is 240 volts versus 120 volts. But this controls all of the AC functions of the boat, and then this controls just the air conditioning system, which draws a lot of power. I am hoping that I will be able to run the air conditioning off of this system as well. This boat's just got all sorts of upgrades. Look at that water maker. If you didn't see that video, go check out the very last video. I installed this Seawater Pro water maker. This thing is top notch. I'll leave the link in the description for where to get one of these. But I love this water maker because you can set it up however you want. Instead of having one contained unit, you can separate the pieces. The filters are easily accessible right here. The panel's right in front of you. The high pressure pump's right there. It's just a quality setup. All right, so right now I am making the connections in the engine room to the electrical panel and to the generator. So here's what I've got going on. Last night I prepared all of my wiring. This is my bundle of wires that's coming from the inverter. So basically what's going on here is these two wires go to the electrical panel. So what I did was I connected the two electrical panel wires to the output of the inverter using these really cool crimpable butt connectors. They're thick tin coated copper, so they're very strong, and then shrink tubed them, and it came out beautiful. It was a very good connection. And then these two wires, which are also coming from the inverter, are the inverter's input. So this is where the power goes into the inverter from the generator. So inside my generator control box here, that's my little diagram explaining what all the wires do. Right here, the generator is obviously set up for 240 volt split phase power. So the U2 and V1 terminals are looped, and then U1 is one phase, one leg of the phase. V2 is the other leg, and then U2 or V1 is the neutral. So this is the neutral wire to the panel. And then one of these, I'll figure out on my diagram, is the neutral wire to the inverter. Those will be connected all the time together. And then the two power inputs to the inverter are going to see the two legs of output power from the generator. So essentially the way this is going to work, the generator, when it's running, is supplying 240 volts to the inverter. The inverter over there in the aft is transferring the power via a transfer switch to the panel. So the inverter is powering the ship's load. In addition to that, it's charging the lithium batteries. When you shut the generator off, the inverter instantly kicks over to battery power, starts inverting, and sends the same power, except inverter power, to the electrical panel. So you will never lose power, in theory. Generator supplies power when it's running and charges the batteries. When you shut it off, inverter switches over to inverter power and still powers the panel. So let's connect some wires, shall we?
Back with another one of those block rocking beats. Back with another one of those block rocking beats. Back with another one of those block rocking beats. Back with another one of those block rocking beats. Back with another one of those block rocking beats. Back with another one of those block rocking beats.
Alrighty, so I think I am almost ready for the moment of truth. I made all my connections in here. Everything's labeled, everything's loomed and nicely fastened, not going anywhere. Now what I did here, I'm gonna loom this too, and I'm gonna fasten it so it can't move. But I took a piece of bilge hose and I used it as like big, thick, heavy-duty wire loom, and I ran it all the way through the bulkhead. So, you know, we're well protected. All those AC wires are well protected. I'm gonna do a little cleaning up here. I'm gonna double check my wires based on my diagram, and then we're gonna give it a test. So you remember what I said about the inverter capacitors needing to be charged, and I'm gonna do it via AC instead of DC because it draws an extreme amount of amperage. If I were to just connect the batteries, it's gonna go big spark. Probably blow the fuses in the batteries or blow something else. We don't wanna do that. So I've left the battery bank disconnected. I've got a couple final connections to make battery-wise, but what we can do is test the AC side of the system. So what I'm gonna do to test that is double check all my wires on both sides first, then shut the breakers off on the inverter, fire up the generator, so we should have power going through the wires to the inverter, but not into it because the breakers are off. Then I'll test with the voltmeter to make sure I have the power I think I have where I want it. And then I'll turn the breakers on. We'll see what happens. I'm gonna get double checking now. Alrighty, so according to my diagram, everything is as I want it. The breakers are off. Let's go fire up the Jenny, see what happens. Alright, so I should not even need to do anything on the panel because basically the inverter will be outputting AC and it'll just dead end because I'm on shore power right now. So let's fire it up. This reminds me of the moment I finished the off-grid system in the Hatteras, and it's like the moment where everything's gonna blow up if something's wrong. I'm confident everything's right, but if it's gonna blow up, it's gonna blow up now, so let's see. So good. Let's go down to the inverter and flip those breakers on, shall we? I'll just turn the input breaker on for now. Oh, this is crazy. This is crazy, crazy, crazy. All right. Unit is off. AC breakers. Output protect and input protect. All right, let's go input on. Okay. Input breakers on. Turn it on. Oh, I know why. I accidentally shut the breaker off on the genset itself. Back to the inverter. Now, if I'm thinking correctly, I'll probably hear the generator labor. Nothing. You know what I'll do? Let's see if I have power here. Let's see if I've got power where I want it. So I should have 240 across hot 1 and hot 2. 240. And then I should have 120 across the neutral. 120, and then off the other leg I should have 122. Yep. And then I should have 120 off of the ground as well. Alright, so I just did some reading in the manual, and it has been brought to my attention that this inverter will not power on unless it has DC power going to it. So that means that I need to connect the batteries and hope there's not a big arc and a spark. You'd think it's smart enough to know. It's hard to say, but what I'll do is, which is weird though, because the thing should be able to turn on with just AC power. If the batteries went completely dead and the BMSs shut them down, that would mean that it's not capable of turning back on. Maybe if the capacitor's charged, maybe that's what it looks for. Either way, I guess I'll connect the batteries and see what happens. But the wiring is correct, so that's good. The dip switches were wrong, so I fixed that. It's set up for my application now. And yeah, let's see what happens. All right, time to boot up the batteries. First, power on, power on. Oh, they all turned on. Probably hit the buttons just to be safe. Okay, left side, power on. Alright, so at this very moment, I should have 48 volts DC, 52 on that bank, 52 on that bank. Alright, what I'm gonna do to try and charge this inverter up is I'm gonna use this weenie alligator clip. I want to do this because if it's gonna burn anything, it can just burn this weenie clip. Alright. Oh yeah, it's as I thought. I killed my weenie alligator clip. Better that than something else. Alright, let's try again with the other alligator clip. Let's try again with this one. Alright, I think that charged it. Let's see, we theoretically should be able to put this on. Oh yeah, she turned on. Wow, look at that. Grid 240 She's in bypass mode. Holy crap. Woo! Alright, whoa. Oh yeah, I just smoked my alligator clip. Alright, but it's staying running, which means now that it has grid power, it's happy. So that's good. That's good. I'm glad to see that. Alright. I'm gonna hook the batteries up and we should be good to go. Alright, we are good to go. This is the wire for the smart shunt. I'm gonna neaten all that up, but let's boot her up. She's on. Alright, I'm gonna get into some testing and I'll report back. Alright, so we are in business right now. As you can see, that's the smart shunt. Victron. We're charging at 130 amps right now. And what's really cool is that there's a potentiometer that you can adjust. So watch this. I'm gonna turn it down and you're gonna see the charge rate correspond. So I'm up here, gonna turn it down now. That's a little down, turn it down more. So now we're charging at 40 amps. Still a pretty good charge. Fans adjust automatically on the inverter. Alright, so right now we're going to take a look at the Epoch app. Dashboard, you can see all the batteries. You can see that they're a little bit different from each other, but I've been using the batteries for over 24 hours, so when you recharge them is when they really balance. You can actually see every single cell in every single battery. You can see the biggest differential between each cell. Pretty damn cool. All from one page on the app. I already updated them. Pretty awesome. Pretty cool. Definitely liking it. Alright guys, so flash forward 2 months. I am in the Bahamas now. The very next video that you're gonna see is episode 1 of my Bahamas travels. This has been by far the most epic, beautiful, fun, enjoyable, everything trip that you could even ever imagine. It has just been spectacular. To conclude the off-grid system video, I'm sure a lot of you guys are saying, where are your solar panels? How is it really off-grid? Well, I guess it's not completely off-grid. It's more of an off-grid hybrid, but the SunGold Power Inverter has an MPPT solar charge controller built into it. So if I want to add solar to the boat, it's as simple as hanging some panels, running some wires downstairs, and it's good to go. No extra components needed. However, I am pleased to tell you that the system is working far better than I ever anticipated it to work. Essentially, minus my air conditioning, if I don't use the air conditioning, 8 hours of generator running and charging equals 72 hours of running the boat off of the batteries. Like, come on, that is ridiculous. 8 hours of charging the batteries equals 72 hours of boat running. That's the fridges, the lights, running the stereo, you name it. Just not the air conditioning. However, on those hot nights, I can run the air conditioning off of the batteries. It will run the air conditioning for 14 hours on a full charge, in addition to everything else on the boat. So I honestly find myself most nights running the air conditioning, just because it's way more comfortable down in the room with the AC on. I'm in the talks right now of installing an ultra efficient chiller system into the boat. That would be a game changer. But you gotta think, right now what this air conditioning system consists of is a fresh water pump, a water circulation pump, a massive compressor, and then each air handler has 2 motors, except for the guest staterooms that have 1. So you're running like 14 induction motors when you're running the air conditioning. Frankly, it's impressive that I can even get 14 hours out of the AC off of some lithium batteries. Massive, massive shout out to Epoch Batteries for making this system possible. If you guys need any batteries for any of your projects, whether it be a home off-grid system, automotive, RV, marine, or anything at all, I highly suggest that you check out Epoch lithium batteries. I'm impressed with them. The link will be in the description of this video. I'm sure a lot of you found this video pretty boring, but I had a lot of fun making it and installing this system, and now the boat is essentially generator independent. I was looking to cut my generator usage in half. Well, I've cut it in more than half, even if I was running the AC, and I've cut it into a fraction of use if I'm not using the air conditioning. The last step of this, I haven't even installed it yet. Right now, we are going to install the panel at the helm so that I can turn the inverter on and off and monitor the system from the helm. Thank you guys for watching. Stay tuned. Bahamas trip is coming up next, and I assure you, it is the most epic trip I have ever done. This boat, it's happy in the Bahamas, to say the least.
What you love and what you have and what you